So in this question, they've given us the coordinates for point A, which are -2, 6, and they've told us that the equation of the perpendicular bisector of the line AB is 2y is equal to 3x plus 5. In the first part, they want us to find the equation of this line or this line segment AB. In the second part, they want us to find the coordinates of B. Now, first, in order to figure out the equation of AB, we're going to use the information that they've given us. We have only a single point, so we have to first figure out the slope. Now, the way we do that is by looking at the equation of the perpendicular bisector. The equation of the perpendicular bisector is 2y is equal to 3x plus 5. And if I write it in the form y is equal to mx plus c, I divide 2 on both sides. I get y is equal to 3 over 2x plus 5 over 2. So now I have the slope of the line that's perpendicular to AB. This is a line that's perpendicular to AB. Now we know that the slope of a line that's perpendicular to a given line is the negative reciprocal of that slope. So if the slope of the perpendicular is equal to 3 over 2, then we can figure out the slope of AB. And if I multiply m on both sides, I get 3 over 2m is equal to -1. And multiply 2 over 3 on both sides, and the slope of AB is equal to -2 over 3. So now we have the slope of the line AB. Now we know that the equation of the line AB, in the form y is equal to mx plus c, is y is equal to -2 over 3x plus c. And since we already have a given point on this line, we know that the coordinates of this point will satisfy this equation. So when x is equal to -2, y is equal to positive 6. So 6 is equal to -2 over 3 times -2 plus c. So that means that 6 is equal to 4 over 3 plus c, and c is equal to 6 minus 4 over 3, and that's 18 over 3 minus 4 over 3, so c is equal to 14 over 3. So the linear equation then is y is equal to -2 over 3x plus 14 over 3. So that is the equation of the line AB. So in the second part of this question, they want us to find the coordinates of the point B. Now, if you just quickly look at a sketch of what they've already given us, they had given us the line, the perpendicular bisector of the line AB. So over here we have this line segment AB. The bisector, the perpendicular bisector, is a line perpendicular to this that intersects this line and divides it in 2 equal halves. So it divides AB into 2 equal halves. And the equation for the perpendicular bisector, was y is equal to 3 over 2x plus 5 over 2. So that's the line shown in purple here. And we also know, now we know the equation of the line AB. The equation of the line AB is y is equal to -2 over 3x plus 14 over 3. So now that we know these two equations, we know that these two lines intersect at the midpoint of AB. So the perpendicular bisector is a line that is perpendicular to AB that goes through the midpoint of AB. So first what we're going to do is we're going to find the coordinates of this midpoint. And the coordinates of the midpoint here are when these two equations are equal. So that means that they have the same x coordinate and the same y coordinate where they meet. So 3 over 2x plus 5 over 2 is equal to -2 over 3x plus 14 over 3. Since both their y values are the same, we simply equate these two. And what we get is, if we add 2 over 3x on both sides, we get 3 over 2x plus 2 over 3x on this side. And let's subtract 5 over 2 on both sides, so we get is equal to 14 over 3 minus 5 over 2. And if we simplify this right here, what we end up with is 9 over 6x plus 4 over 6x, taking the LCM, is equal to 28 over 6 minus 15 over 6. So we get 13 over 6x is equal to 13 over 6. And therefore the x coordinate of the midpoint is equal to 1. The x coordinate of the midpoint is equal to 1. So now we have the x coordinate of this midpoint. That means that when x is equal to 1, what's the value of y? When x is equal to 1, what's the value of y? So at this intersection, x is equal to 1. Now, this value of x will satisfy either of these two linear equations. So let's just take the equation of the line AB again. Now, we know that the point x is equal to 1 lies on this line AB. So that means the value of y can simply be found by plugging in x is equal to 1. So when I plug in x is equal to 1, I get y is equal to minus 2 over 3 x plus 14 over 3, and over here x is equal to 1. So I get y is equal to minus 2 over 3 plus 14 over 3. So y is equal to, which implies that y is equal to 12 over 3. So it is equal to 4. So the coordinates of the midpoint are 1 comma 4. The coordinates of the midpoint are 1 comma 4. So the midpoint of the line AB, is equal to 1 comma 4. Now we also know that the midpoint of a given line is simply x1 plus x2 over 2. So that's the x coordinate, and the y coordinates are y1 plus y2 over 2. Now we already know x1 and y1. Those are the coordinates of A. What we don't know are the coordinates of B. So let's call B over here. Let's call B x2 comma y2. Now the x coordinate of the midpoint is x1 plus x2, and if we say that A is x1 comma y1, if I plug that into the equation, when x1 is minus 2 plus x2, that's what we have to find, over 2 is equal to the x value of the x coordinate of the midpoint. So that is equal to 1. So minus 2 plus x2 is equal to 2, and therefore x2 is equal to 4. So that's the x coordinate of B. Now the y coordinate of B will be, we're going to take this again. So we have the x coordinate. So x2 is equal to 4. And the y coordinate, we know y1 plus y2 is equal y1 plus y2 over 2 is equal to the y coordinate of the midpoint. And we know that the y coordinate of A is 6 plus y2 over 2 is equal to 4. So that means that implies that 6 plus y is equal to 8, and therefore y2 is equal to 2. So the coordinates of B are 4 comma 2. The coordinates of B are 4 comma 2, and that's our answer.